Hello everyone, welcome to my video. In this video, this is the video about learning C for part 3. In this part 3, we will learn about pointer. In my previous video, I already explained about primitive type or primitive variable like integer, char, and floating point. And integer, char, and floating point, what really differentiates them is the size in the memory. So I think I already explained this in in the previous video that for integer for integer it will be have a 4 byte, so it will be 1 byte equals 8 bit, so it will be 4 times 8, it will be 32 bit. And float, it's same, no, I mean 4. And for char, it will be just 1 byte, so it just 8 bit. And in this code, I declare here a in equal 9, so in the memory it will be like this. It will be like 0001001, but since the int have a 4 byte, it will be have the same, it will be have the shape like this, since int have a 4 byte, like 1 byte, 2 byte, 3 byte, and 4 byte. And char, like in my previous video, it's equal 97, so the set of it in the memory, in the binary, it will be like this. Since the char is just 8 bit or 1 byte, its shape in the memory will be literally like this. And a floating point, certain value, 9.1 will be a certain value in the floating point. We can skip it. Now here I declare a char pointer. Normally people will write the pointer char like this, but I doesn't like this way, because I think this way, for me at least, this is a little misleading, because if I write it like this, it's just like saying that, hey, this is not a char variable, this is not an ordinary char variable, but this is a special char variable that is a pointer. That's why I like to write the pointer variable like this. And previously that I said that what really matter in C is just the size, right? Like this, integer have a 4 byte, floating point 4 byte, and char 1 byte. If we declare the char pointer, as you know, I think I forgot explain about pointer. So pointer different with ordinary variable or primitive variable. What pointer one is not like the value like this. What it want is the address, memory address, like this. So its input, if you want to declare pointer, the input is the address. And in C, you can access the memory address. If you want to access its memory address instead of its value, you can just add the symbol ampersand like this. So in here I declare a char pointer, and the input is the address memory of a float variable. A float variable is a floating point. So yeah, this is will work because what she really see in the memory, it's just a binary. It's just a binary like this: 1 0 0 1 1 0, like this. Let's see what if we print this pointer. Let's compile it. Ignore this. This is just a warning because I init a char pointer using a floating point. The compiler just gives me a warning, but this is not an error. It compiled. As you can see, this variable it outputting the random char, and every time I run, as you can see in this part, it print a random char. Why this is happen? Because how pointer char or string in C work is, it will read a sequence. Let me use a whiteboard. So in C for string is equal a char pointer. So how it work? It work like when you want to read a char pointer on a string, it will read in the memory, it will read all the char until it will be find this character. This is called null terminator, I think. I will edit this video if what I call is wrong. Yes, so it will write this until he find this. So as you can see in this the size what I print is different because I read this floating point, and as you can see the floating point has 4 bytes, right? So what happened in this is I read the floating point 4 byte, but in the end, in the 4 byte, it doesn't find this character. In the end, it doesn't find this character. So the char or the C program will read until it find this. That's why the output from the program or this program is random like this, because it's not stopped. And now I want to explain this. What happened if we read, as you know that integer have 4 byte, right? And char have 1 byte. What happen if I read if I declare a integer pointer to from a char like this? Let's see. Oh, I forgot to save. As you can see, unexpected thing happened. What this? Why it's show us 2401? Let's see. In my previous video, I already say that if the value binary of A is 97 and 97 will have a binary form like this, right? So this is 97, and what for the value it have shape like this. I think you understand why it print like that. As you can see in here, we read the part of char in early sequence of memory, and the next is a random. The next is just some random memory, so that's why it's printed like this, but the half of it is a char A. So that's happened. And now I want to explain about, if you already have learned another language, I think you will familiar with this. It's called pass by reference and pass by value. So if you using pointer, what you really do is pass by reference. But if you don't see pointer, if you just pass a parameter like this, it will be pass by value. Let's see. In here, I already built two functions. One is the input is integer variable, and the second function is the input is the pointer variable. Now, what happened when I'm using the first function, that is that its input is a integer variable? Let's compile it, and as you can see, when it's access this function, the A value will be added by 1000. So it's, and when in this line 5, the value of A will be 1009. But when you print it, because you input the variable a in, its value will not change. As you can see, it's not changed because what we pass to the function is a value, not its what we pass is just a function. But what happens if we pass itself or its address? See, the value of a now changed because we literally pass itself to this function. We inform the address, the memory address of A. So we change the value in that address. That's why the value of N now changes.